So, hi, good morning. First, I can see the presentation. Yeah. Sí. Well, yes. My name is Alex. I was here in the previous batch here in Bolt with our startup. It's called Plitix. It's a big data startup. We went well. We got funding, so now we are on next stage working on it, and they invite me to come here and give you a little speech about big data. Let's see if I can tell you something that you didn't know, or maybe you have some questions, or we can share with your startup with me, and let's see if we can do something, or I can give you some idea about big data or whatever. Or otherwise, at least just to get to know each other, because you guys have there are a couple of startups here. I was reading what you have, and a couple of them are actually very interesting. I'm surprised you have a very good level in this batch, and maybe we can at least have a chat if you feel like or whatever. So I'll introduce myself a little bit. As I said, my name is Alex Lopez. I'm a software engineer. I also am MBA, and as I've told you, I am an entrepreneur in this company called Plitix. Before that, I got my bachelor degree in 2005. Then most of my life I've been working on my own. First, I have a job for a little while, but then I made my MBA and started my first startup, which actually didn't work. We worked for 5 years. At the end, it didn't work out, but at least I can use all what I learned from my errors to don't make them again, the same mistakes. Then I was working as a freelance developer in a few projects in national and international. And then there, while I was working as a freelance, I met my partner, Morten, that was here a couple of weeks ago, giving a speech about growth hacking. And we started Plitix. He had that idea. I really like it. We started developing, prototyping, and now we're here. We went very far. It's been a very intense 1.5 years, more or less. Now, after we got funding, we are intensively working on it. We are in a nice house in El Palo. If you want to come to visit us, our office. So, big data. This concept, big data, it's right now it became very popular. I hear a lot of people talking about big data. Uh, Nobody seems to be able to describe or define what exactly big data is. I think it depends. It depends. I've seen a lot of definitions and descriptions for big data, and the thing is, there are quite a few definitions and descriptions for big data. It depends on what you mean with that, or what are you interested in. What I think at the end, big data, it's a lot of data, a big amount of data, but it brings consequences when you are dealing with so big amounts of data. Uh, you need new techniques, new technologies, new strategies to work with that. And that's why the concept itself, which is actually pretty simple, is big data, a lot of data. It becomes interesting because it affects the technology, the market, and there are a lot of startups appearing around big data. The thing is, what I think you should ask yourselves, it's how can big data help my business? It even can it even help my business, and how can I use it to make my business better, to make money out of it, or to make better decisions, etc. So, key principles. First, distributed storage. When we are dealing with terabytes, petabytes, whatever you want to say, it's impossible to store all that information in a single hard drive, or in a single computer or server or whatever. Usually, you need to split it. You need to distribute the way you store your data. That is for the system guys or whomever that is interested in systems. So we can deal once we build distributed storage, we can deal with bigger amount of data, and also we can have redundancy, we can have backups, and once we have the technology that let us work with that. And then of course, distributed storage means distributed data processing. If I have all the data in different physical places, we need new techniques to be able to compute, load, make calculations, queries, consult that data in a distributed way. So new techniques and of course parallel processing. The idea here, what we're trying to do with big data is to be able, if we're querying something in the database, if we're calculating some average or whatever, that we can do pre-calculations in different places and then put them all together. And that's basically the techniques that we use. And it brings us new possibilities. Working with big amounts of data helps our business intelligence staff to better understand what we're doing, in which situation we are. If we are talking about stock, how is our stock doing? If we need to buy more, if we are not selling something, or cross data between how people work in my company, which resources I have, or if you can find relationships between different departments. That's all the things you can do with big data. And you can also do predictive analytics. Once we have the technologies that let us make calculations, make queries over big amounts of data, I can go and take all the past data, that information that I've been collecting for a long time, and use it to make estimations, predictions of what's going to happen next. I can compare, so last 10 years, this month it's been like this, or under this and that certain conditions, I get more or less sales, so I need to change this or that. That is super important. That's probably even for the weather. I don't know if someone from Urban Clouds has been here. Urban Clouds. They are a company that was in the previous batch here. Yeah. They have the bike guys. I call them the bike guys actually. Yeah. So they have a mobile weather station that I was actually calling at the beginning. And so you can get all that data and make predictions about weather, pollution, etc. If you can process a lot of past data, you can more or less figure out or expect what's going to come next. Okay. So, as I say, I'm going to keep it short. I'm just talking about what is popular, what you probably heard if you talk about big data technologies or techniques. First, NoSQL databases, and I want to highlight MongoDB not because I don't think it's the best, or it depends on the use you want to give it, or it's not the one used in biggest companies, but I'll explain you later why it's interesting that you keep an eye on MongoDB. When you say NoSQL, I don't know if your profiles, I expect that there were probably some technicians, some developers here. We are developers like me. We've been very used to work with SQL database, SQL queries and stuff. And now it changed. Well, not necessarily changed, but if you're working with big data, you probably switch to NoSQL databases, which have a very different way of working. It's the relationship with the SQL database is little, at least at the end it's database, you store data, but the way you work, there are no relationships between tables. Now here you call them collections. It depends on the database. It's a big change, actually. MapReduce, it's the most popular technique of big data processing. I'm going to explain it in the next slide. As I was talking, when you want to make a calculation on a distributed system where you have a lot of servers, there are ways, there are techniques that you make intermediate step calculations on those servers, and then adding until you have the final calculation. You don't need to have all the data to put everything in memory and then make the calculation. Big data techniques allow you to do that in a distributed way. Hadoop is a big data framework. It's written in Java. It's probably the most extended and most popular big data framework out there. It includes distributed computing, and also it has its own file system. It's called HDFS, and it's basically a system that you can have very, very large files, and in an abstract way that you don't notice, Hadoop physically splits these files in different locations, because those files are database alike, petabytes, terabytes, something very big that Hadoop splits for us in a way that we don't notice, in a transparent way, and it's able to work with that and make the calculation, etc. Hive and Peak are Hadoop consumers, like clients. It's Hadoop. It has the file system in that we don't necessarily need to understand, and it allows you to use drivers like Hive and Peak to consume that data, to request, to write and read data from the Hadoop file system in a way that is more familiar for you. With Hive, you use SQL-like queries, and with Peak, you use Perl-like queries. I don't know if you guys know Perl. I don't know if one of you guys is even a developer. I expect so. Okay. So, okay, this is a bit cut there, but anyways, it's stolen from the internet. I didn't have time to make a chart like this. So thanks for the author, whomever it is. So this is what I was talking to you, the MapReduce concept. This is the most, as I said, the most popular, the basic technique we use to make queries, calculations with big data. So it's based in a two-steps process, but you can split particularly the second step in more sub-steps. But it's basically you have data. It says DVD, CD, DVD. I have different. Let's see, that's a dictionary, and I have different elements. Okay, so the map stage, I get from every element, I get the name and give it a counter, which is 1. So from here, I get Blu-ray, 1 DVD, another DVD, another CD, and from the second, 3 CDs, and from the third, what you see here. So in the map part, I get from the data, big data, the data we use in the NoSQL. It's unstructured. It's not like SQL tables that you have this and that field. In NoSQL, in databases, every row of the collection, every record can have any data. It's absolutely unstructured. You'll get used to that if you work with this. So here in the first row, I have DVD and Blu-ray. In the second, as I said. So in the map stage, I put a counter on every of the words. Okay, let's say the thing is, I want to know how many of each one do we have. First stage, put a counter, and in the second stage, I just group by word. It's very simple. I group by word and make the sum. Okay, and that's it. But here's the thing. I can have these in separate locations, in different servers, and then I populate them with a number. And in this stage, I can make a pre-calculation of these two, and then another separate of this, and another of this, and put more stages. If I have a lot of them, I just go adding and adding and adding, and at the end, I can have the final results.
What if you figure out at the last step in the output data, I want to show it differently? They want to have more maps instead what you would like to have at the initial output. Can you make changes in that then?
Yeah, of course. I mean, this is the simple example. You can make averages. You can populate any data you have. I mean, it's not only this. From the first stage, You can take keys or pre-calculations or whatever, but usually map means from this data, from this record, you choose what to map, what to bring to the next stage.
Exactly.
So from all the data you have, that can be any, you choose what are you bringing to the second stage, okay? And then in the reviews, you make the calculation. Here is just adding. You can do anything else. The tricky part, the tricky thing is this stage can be, I can just sum these two, and then with the result, I sum these, and I get the same final result. So that's a way to understand the distributed processing that I was trying to say. Okay, but we can discuss it further. I don't want to be so. This is a bit boring. I can discuss it further with you if you are interested. Okay. So as I said, MongoDB. Why I go a step deeper into MongoDB and why I book a slide for it, because I know you had a very intense session of big data last Wednesday. She was talking about big companies, technologies, like big enterprise systems, technologies. Well, I think now we are startups. We need to be up and running very fast. We don't have big budgets. So MongoDB, it's a NoSQL database that lets you work with all the big data tools in a big data paradigm. It lets you work with that. It's open source. It's free to use. It's super fast to install and to set up, and it has drivers with all the languages to connect it with your application. And yeah, it's very simple to use as well. So you can easily switch to a SQL traditional model to a NoSQL using MongoDB with a very little effort. And if you really need to start using big data, and now that you are startups, until you become big or you get money, you are always prototyping, right? It's what we do. We want to be fast in the market. We are prototyping, we're working fast. This is a super good tool to prototype and even to work in a medium size levels. Then if you go very big, maybe you probably want to switch to Hadoop or whatever. But trying to work with Hadoop at this stage, I think it's crazy. Okay, it's a very, very big thing. I'll go for MongoDB. So it's, as I said, no relational, no SQL. For your information, in MongoDB, instead of tables, you use collections, and the collections don't have relationship between them. You make the relations, and you keep them with your code. But Mongo will never check that an ID is correct in another collection or whatever. That's on you.
It's not dangerous then. Maybe dangerous. Somebody erase a table and have no relationship with another.
Okay, so that's it's a complete concept. First, in NoSQL, the data is not structured. So in same of the rows, you can have an ID, and in others you don't. And it's how it is, because it is thought for very unstructured data, very variable data. Like these guys, the bad guys with the weather station. If I break, let's say that one of the sensors breaks, so I won't be sending CO2 information for a while. But should I stop the system? In an SQL, it will say, no, I don't accept this data because you're not sending me CO2, the column. But it's not like that in NoSQL. That's the first. And the second, I've been a developer for a while, and it's a very, very good technique and very responsible technique to set up the constraints. But do you actually use them? I mean, imagine that once you fall in a situation that you are breaking a constraint, you're really fucked up. I don't know if you agree, but you usually keep your code safe, so the database is always stable and clean. And if you don't, there is Yeah, it can break but you don't want that in your system either. I mean, you always want to prevent that from happening from the code. You never let the database to break and throw a constraint error. You know what I mean? I know what you're saying, and you're right, but it's hard is here. The thing is, MongoDB, NoSQL database are not thought for relationships. But if you don't want to work with 3 databases at the beginning, if you go to MongoDB, you have to deal with that and work the relationships yourself. But it's actually, it don't provide that technologies because it's not thought for that. But we use it for that, so we have everything in one database. Now in Plytix, we use 3 databases because now we can bigger. And then we have a database for the applications, users and stuff, another database that collects the data, and then we map reduce, aggregate the data, and put the result in another database that is for checking. Now we are at that stage, but when I started prototyping, it was like,
Okay.
Then let's see where with the map reduce concept. It has a concept that is called aggregation pipeline. It's for some of the map reduce operations, like adding some. It has a more intuitive and easy to use tools that work very fast to make simple aggregations. If you want something complex, then you can go to MapReduce functions. Okay, and as I said, it's super fast to start working with MongoDB. All right, and question.
Yeah, I would ask about some drawbacks from MongoDB. Like
Some
drawbacks, minus, because in my opinion, not everybody needs it actually. Also, there's not so many ORM, because for example, for PHP, it's only I think 1 or 2 ORMs, like Doctrine, and also I don't know. From my point of view, it's rather hard to understand the MapReduce techniques. I think that like joins and all stuff from the scale is more intuitively understandable. So
okay.
I think that not everyone needs really Mongo.
And I hope you didn't understand that.
Yeah, but so can you maybe in a little more detail say where is the line where someone needs to switch?
Yeah, yes, of course. I'll try. No, of course, not everybody needs not MongoDB, not even not even NoSQL and not even big data. It depends on your applications. Okay, so when will I consider doing this, or better, when not? When I wouldn't. Okay, if you have a very strong relational database model, forget about NoSQL. Okay, if you have books, authors, libraries, book collections, blah 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 blah, forget about NoSQL. If this is what you're working with.
Yeah,
okay.
For machine learning, actually, for example, there's very often situation we have such data, a lot of inter-object connections. So, not always in predictive analysis you can switch to. Sometimes there are a lot of relationships between the input points.
But I have to disagree there. Okay, when you're working with predictive analysis, usually are working with data that it's super variable. Okay, even if you think about it, I'll say something that is a bit weird, but I developed a shop. I have it's a very secondary project. I'm with Morten as well. It's a ham shop. We sell ham online. Okay, and I realized, I said, okay, let's give it a try to MongoDB for this, which is not ideal because you usually have order which has a few products. We have a few whatever prices, but one thing. When you have an order, it depends on the customer. It can give you different data. Some will give you email, some will give you phone, some others won't. And with SQL, it becomes a bit struggling. I'm not saying NoSQL is the best for shop system, but I'm putting here the strengths. Okay. Second, what happens when you are when you keep the bill? Usually, you keep a link to the product that you sold, right, in the purchase. But what happens if the product changes the price after you pay? You need another extra table to store the final price that you sold, because you never know at which price you sold that product on that purchase. Okay, so those situations become weird in SQL. They are not fluent. You know what I mean?
Yeah.
But it's not the ideal case. The ideal case is like the bike guys. Tomorrow you put another sensor in you start measuring whatever. So I start getting data that I was not getting before. I don't need to do anything to accommodate that data with the rest of the data. When we make when I make map reviews or whatever, it will just ignore regarding the O2, if it's what I'm having, the O2 sensor, I will just ignore the past records. Okay? About all ORMs, there are, but if you're using MongoDB as a big data technology, no SQL technology, why would you want ORMs?
Because for me, like it's sometimes like the line cases that for some like fields we need some relation, for some we don't. Like, it's from my experience, maybe I don't know. So at some point you need to implement somehow. So
Yeah, no, but I mean, and for Implytics, for the application stage, I will switch to a SQL database.
okay, so you will just work with data with Mongo.
Yeah, I started with everything in Mongo because it was more simple. But now, if I don't know if I will do it, but I could consider switching the application database, like users, products, folders, blah, 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 to SQL database, and leave the data part outside. But what you say for business intelligence, I disagree. Would you, in a SQL system, imagine you have tons of data. What you end up using? You use views, right? You don't cross all the tables for every request. So you need to define a view, because you bring data from all the tables and put it all together in a view so you can query a view. But what happens if new data comes? You need to create a new view, etc., etc. So with NoSQL, with data, it's already solved. Okay? Or sometimes when you want to store very unstructured data in SQL, what you do? You serialize, right? You serialize a string with a dictionary or whatever. This is native in NoSQL. Every record is actually a JSON-like structure, dictionary, list, or whatever, natively. Okay? So no, for business intelligence, I have to disagree because it works super smoothly with NoSQL. Okay, way better than SQL, but no way to compare. For the application, if you need an ORM or whatever, fair enough. I don't think everybody needs MongoDB or SQL. It's just putting here on the table if you are considering or you have needs of big data, that this is what we need to discuss. If you ever have big data needs or you should be using it or not. Okay. Something else?
How many long time have been MongoDB in the market?
It's okay. I'll make it short. I think kind of 6, maybe more, because I'm not very good with this.
Yeah.
Probably more.
It's possible that ES2L it's Oracle.
Oracle or any of them. Yeah.
Be developing something like Mongo, because if we change, we have to learn everything about the new one, and that's could be kind of disturbing for any programming.
But the thing is, do you need to change? I mean, if you do, then you have to learn. But even if Oracle or MySQL or whatever, developer NoSQL, it's NoSQL alternative, then you need to learn how to work with NoSQL.
Yeah. Anyway.
I mean,
Okay.
there's no way around it. Yeah. The thing is, do you need it? If not, forget about it.
In the major cases, what do you think? It's going to NoSQL database fusion.
I think they are getting a big piece of the market, but they will never get all the market because it's not better than SQL. It's just
Different.
more appropriate for under certain situations. Okay, that is, it's obviously getting a big piece of the market. If people will be using NoSQL to write shops like I did, no, I don't think so. I just wanted to try. Okay. Something else? So now, if any of you.
Yeah, the one-to-one. You're going to do the one-to-one inside?
Yeah, exactly. I go to the meeting room, and if any of you feel like doing a one-to-one, I'll be happy. Okay.
Great.
Thank you.